Cubaan suara 1 2 3. Cubaan suara 1 2 3. Hello, hello. Cubaan suara 1 2 3. Cubaan suara 1 2 3. Hello, hello. Cubaan suara 1 2 3. Cubaan suara 1 2 3. Hello, hello. Cubaan suara 1 2 3. 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 Cubaan suara 1 2 3.
Apa?
Cuba 1, 2, 3. Cubaan suara 1, 2, 3. Assalamualaikum doktor.
Ya, Assalamualaikum. Boleh dengar.
Alhamdulillah. Kita mula jam 8.15 ni doktor.
Ya,
Kita mula jam 8.15 ni.
suara saya okey ya?
Okey doktor, dengar jelas. Clear.
Okay. Saya kali. Sorry.
kita masih menunggu participant untuk datang. Satu lagi 2 minit kita akan menunggu.
You have 10 minutes to finish your research. You rush into searching it.
Bismillahirrahmanirrahim. Assalamualaikum and very good evening everyone. Welcome to today's Physics Appreciation Week POW laptop program with the topic towards the evolution of physics. My name is Muhammad Harith Ikwan and I will be the moderator for today. This talk is brought to you by Physics Student Association's Fakulti Sains Gunaan UiTM Shah Alam. Before we begin, I would like to give a short briefing about our live talk program. This live talk is one of the main programs which is Physics Unit's Physics Appreciation Week sub-program. Physics Unit's program is included with another 2 programs which are Digital Arts, Celebration of Islamic Scientists, and Kahoot, Who's the Scientist and What are their famous equations. The main idea of this program is to strengthen the bond between all physics students and prove that physics is not just about study and equations, but to make something valuable and fun out of it. So, without further ado, let us begin by allowing me to introduce to you to our speaker for tonight, Dr. Ahmad Najib Alias. Assalamualaikum, Doctor.
Waalaikumsalam warahmatullahi.
Alright. So, for your information, Dr. Ahmad Najib Alias is a senior lecturer in physics, Faculty of Applied Science, FSD, in University Technology Marang, Cawangan Perak, Campus Tapa. He obtained his doctorate, which is PhD in Polymer, in 2015 from University Technology Marang, Malaysia. He has also been appointed as Coordinator of Research, Industrial Linkage and Community for FSD from 2013-2016. And he also has been appointed as the head of the Study Center, Faculty of Applied Science, FSD, University Technology Marang, Cawangan Perak, Campus Tapa from 2017 to 2019. I am pleased to inform you that Dr. Ahmad Najib Alias is with us today as our speaker. He will share about the evolution of physics. Before I hand the mic over to Dr. Najib, just a few housekeeping notes before we get started. This live talk is broadcast on YouTube account Physics Student Association UiTM Shah Alam and is accessible through the link of StreamYard for the committee. This live talk will take around 1 hour and 30 minutes. Dr. Najib will share the topic for about 1 hour and followed by Q&A session. And we also invite your questions for our speaker, so please feel free to send them to the YouTube comment area. And I will bring them up during the presentations, and we will also have time for questions at the end. Now, without further ado, I will turn the time over to our speaker today, Dr. Ahmad Najib Alias. Dr. Najib, the table is now yours. Please welcome.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, okay. So, can you see my slide? Still loading. Sorry. Still loading, yeah. Okay, alright. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Mr. Haris, uh, and fellow students. Okay, so thank you for inviting me to this short about discussion about the evaluation of quantum physics and chemistry. Why I'm say that the evaluation of quantum physics and chemistry? Because when we talk about physics, okay, so when we talk about physics, we cannot. Physics is the main subject in science. Okay, so when it is a main subject in science, so we cannot say that physics is not important to the chemistry and physics is not important to the biology. So when we talk about science, when we talk about physics, so physics is interdisciplinary subject. So bila kita sebut sebagai fizik je, dia merupakan kunci kepada sains. So bila dia kunci kepada sains tu, so therefore we can say that physics is very important to chemistry and physics is very important to the biology. Okay, so for example, when I'm doing my PhD, even though I'm my background in physics, but when I'm doing my PhD, most of my research more on towards in polymer science, polymer chemistry. So, but for me, is in physics there is a lot of things that related with chemistry. So kita tak boleh nak katakan bila kita belajar physics hanya untuk physics saja. So it will be interrelated antara satu sama lain, from one to the others. Okay, so a little bit introduction for myself. Okay, so I have wrote 2 books. Okay, Asas Quantum Mechanics. Okay, so this is a fundamental of quantum mechanics that I wrote. Has a physicist, has theoretical physicist. One of the requirement to share our knowledge is to write a book. Jadi siapa-siapa yang berminat untuk dapatkan buku ni boleh dapatlah di Lazada and Shopee. The publisher is USM Press. Okay, so this subject I wrote is very simple, fundamental and mathematics equation. So to ensure that the students can understand what is the quantum mechanics. Okay, for my second book is more on research on advanced in material science. So these 2 books that I have wrote, and inshallah in next year 2020 I will produce another books that is introduction to modern physics. Okay, so the purpose I wrote this book is to share my knowledge to my student. Okay, nak kongsi pengalaman lah. So nak kongsi what is the best practice to learn in quantum mechanics. So in today, or the evaluation of physics that I will talk about today is more on the revolution in quantum mechanics. Okay, so revolution in theory. Okay, so what is the history of the quantum mechanics from earlier beginnings until now? Okay, so because the quantum mechanics, most of the students say that the quantum mechanics is very tough to be learned. It's very difficult. For me, it's very simple because I have wrote this book. That's why I'm writing this book. Because for me, the quantum mechanics is very simple. If you know what is the fundamental of quantum mechanics, okay. So after this, I will share with you the basic idea about the quantum mechanics. And I'm not teaching about the quantum mechanics. I just give you some keywords to you to understand what is the quantum mechanics. If not, you may say that apa benda ya quantum mechanics kita belajar tak faham langsung kan. So it's not my way to understand in physics. That's why if you understand deeply in physics, if you understand the concept of physics, it's very simple you to understand about the phenomena in biology, in phenomena in chemistry. It's very simple. Okay. Okay, so about the timelines for computational physics and chemistry. Okay, we start in 1960-78 by Isaac Newton. Okay, so Isaac Newton has introduced about the sorry, I'm not feeling well today. Sorry about that. Okay, about the classical mechanics. Okay, about the classical mechanics. So we have three Newton equation. Okay, and then it's widely been used in classical mechanics, in mechanical engineering. Okay, and then after that, in 1816, one of the famous scientists named James Maxwell, have introduced a new phenomena in electromagnetic wave. He explained the behavior of electromagnetic wave. Unfortunately, he died very young. He did not continue his research. Okay, until the problem came when the black body radiation. This is the trigger to create a new fundamental or new theory in physics and chemistry. Okay, so after that, Niels Bohr has introduced the atomic model. Okay, and then after that, the Schrödinger, okay, introduced a Schrödinger equation in 1926. Okay, and from here, there is a lot of invention, a lot of theory has come, especially in electronic properties of material. Okay, because I'm talking about the electronic properties of material because this is one of my research field that deal with molecular orbital. Okay, and then in 1916, you have Waterkorn and Popper have introduced density functional theory, and then semi-empirical. Okay, and then in 1960, in 1980, sorry, in 1980, the molecular dynamics has been introduced. Okay, why the scientists keep on going to do the computation in physics and chemistry? Because one of the things is we want to reduce the cost. Okay. Salah satu kenapa wujudnya berlakunya perubahan sifat electronic calculation, computation in physics and chemistry. Salah satu daripadanya adalah kita untuk jimatkan cost, because when you do the experiment is very highly cost. Ia sangat mahal. So bila dia sangat mahal tu, so we need to reduce the cost. So and to get the optimum output. So this is um, one of the things that scientists need to do. Okay, scientists need to do is to get a new idea, to get a new innovation, how to reduce the cost. Okay, kalau you pergi pada industri pun, uh, orang industri pun mesti akan kata macam mana kita nak reduce the cost. Okay, now in 2020, early to that, okay, the introduction of machine learning. Okay, so the introduction of machine learning has come. And this machine learning has been implemented in electronic properties to do the prediction using a data mining and using a statistical method, advanced statistical method. So this is the machine learning. Okay, machine learning also can be used in a lot of IA, artificial intelligence, and then Internet of Things. So a lot of things deal with machine learning. Okay. Okay, so about the optics, the timeline for optics, the evolution of in the optics. Okay, we go back to the uh, Osmania Empire. Okay, Osmania Empire. So we have a lot of Arabic scholar, Islamic scholar at that moment. Okay, one of the famous is Ibn Haytham, Hassan bin Haytham. So he wrote a book, The Theory of Optics, and widely until now, this book can be read. Okay, so after that, we have a classical optics, deal with Newton, deal with Young and treatment, okay, deal with hygiene principle. So this is a classical mechanics. Okay, as I mentioned earlier that the merge of quantum optics start when the scientist has found the black body radiation. Okay. Black body radiation tu merupakan satu pencetus kepada a new theory. Okay, mm, after that, uh, de Broglie and Planck has explained the theory of black body radiation using the quantum approach. Okay, so what is de Broglie principle? As you learn in diploma in science and in a degree in modern physics. So de Broglie principle is the wave duality principle, which the electron can be any entity can behave like particle, and any entity can behave like a wave. However, nowadays, in current situation, de Broglie principle has a lot of high, uh, obstacle to implement in the new technology. Banyak halangan untuk de Broglie principle. Okay, and then in 1926, we have a new concept in optics, that is a photon. Okay, so photon is a new concept in optics, has been introduced by Lewis. Okay, so in chemistry, we familiar with Lewis. Okay, Lewis structure. We learn about the first molecular orbital. We learn about the Lewis structure. Okay, however, he also has give some ideas about the lights, because the Einstein has invented the photoelectric effects, and then uh, And then what Lewis say that, Lewis say the photon, a light, the packet of light, why not we say that the packet of light is a photon? Kenapa kita tak bagi tahu bahawa cahaya tu bersifat seperti elektron and dia adalah discrete and it is a photon. So this has been introduced by Lewis. Okay, and after that, in Second World War, Tungsten and then Theodore Maiman has invented a laser, light amplification, stimulated emitted radiation. Okay, so the main purpose for laser is actually for war. Okay, the main purpose dia adalah untuk peperangan ya pada waktu tu. And then in 1965, in 1995, Professor Lamb, one of the Nobel laureate, argue about a photon. Okay, he is only one Nobel laureate that argue about photon. Okay, so after he died, there is no research on how to implement a new idea about photon. If Professor Lam still alive until now, maybe, so we have another quantum theory of light. So because he said that when he do the experiment about laser and maser, so when they use the theory of photon, a lot of things cannot be explained well. So itu sebabnya dia kata kita have to look a new theory in photon. However, in 2010, photon counting has, in this year, photon counting, how to count the photon has been new. This is in a new area in research. Okay, photon counting. Okay, because what we have here, okay, the image of electronics, using the electronics, so we can count, we can prove that de Broglie principle, which some of the scientists are not agreed about the de Broglie principle, so has been look deeply into single photon counting experiment. So this is the timelines for quantum theory of light. Okay, about some history of semiconductor. Okay, most of the semiconductor has been invented in Alexander Graham Bell Laboratory in New Jersey. Okay, so there is a lot of electronics devices such as transistor, bipolar, light emitting diode, tunnel diode, laser, gun, and charge couple device. Even our fiber optic has been invented in AT&T laboratory. So there is a lot of device, and then the explanation of this device are using quantum mechanics. So one of the important things that you learn about quantum mechanics, you can apply the quantum mechanics to explain the behavior of quantum mechanics in the semiconductor devices. Okay, so and then there is the timeline in quantum mechanics. Okay, in biology. Okay, so why I'm talk about in biology? Because in as I told you earlier that fizik ni dia adalah ibu kepada segala sains. So a lot of phenomena can be explained using physics. So kita tak boleh nak pisahkan antara fizik dengan biologi. Kita tak boleh nak pisahkan. Kita tak boleh pisahkan fizik dengan kimia. Kita tak boleh pisahkan. Because a lot of things has been explained by using the physics phenomena. Okay, Haris. So I think for introduction cukup setakat itu je. Okay, alright. Thank you.
Alright, Dr. Nadir, thank you. But do you mind sharing with us, Doctor, about the application of quantum mechanics in material science and technology?
Yes. Okay. Alright. So I share you about the evaluation of uh, physics, computational physics and chemistry in material science. Okay. Okay, we know that there is in basic physics we have Newton's law and we have electromagnetic waves. Okay, so Haris, I just want to ask you what is different between magnetic field and electrical field? Can you hear me, Haris? Okay, so the difference between the electrical field and magnetic field is different. Okay, so the electrical field actually something that okay, for example, if we have a, a big particle, and we have a simple test charge, and when this big particle is not moving, okay, it's not moving, and this test charge attract to this big particle, and we say that this big particle create the electrical field. Okay, so this is the difference. This is the electrical field. So if we have a big particle and we have a test charge, and this test charge is not attract to this big particle, it's nothing happen. Okay. However, when this big particle start to moving, rotates, as long as it's moved, so this test charge start to interact with this big particle. So therefore, this big particle, we can say that they create a field, and this field we call as the electromagnetic field. So this is different between electromagnetic field and electrofield and electromagnetic field. Okay, we have a Lorentz field. Lorentz field is the combination between electric field and magnetic field. So this is the basic concept of physics. Okay, uh, the rise of quantum mechanics, it started when we look at this picture. So if you can see about the vessel, so in 90 Kelvin, 900 Kelvin, dia warna merah. Okay, bila kita naikkan dia pada 1750, ada warna kuning sikit, ada warna merah sikit. Bila kita increase the temperature, it start become a white, and increase it become brighter. So this start to explain why this happen. Kepada orang fizik, kalau orang fizik ni, kalau kita sebagai saintis ni, kalau ada masalah macam ni, kita kena tahu apa dia punya problem dia. Kenapa benda tu berlaku. Okay, so this is the scientist. Scientist, kalau kita sebagai scientist is different from engineers. Engineers, you cannot do a mistake. Engineers tak boleh buat mistake. Tapi kalau untuk scientist try to learn. So as we know that Thomas Alva Edison invited bulb. He do many times experiment, and then finally he success to get a bulb. So this is what scientists do. Kita sebagai scientist keep learning, keep working. So this is the nature of scientists. Okay, so when this happen, apabila benda ni berlaku, so we need to explain using a suitable theory. So bila kita pakai classical mechanics, it's not able to explain this phenomena. So that's why Planck came out a new theory that we call as a quantum mechanics. Okay, so also the emerge of quantum mechanics is due to the optoelectronic and optoelectric device. Okay, so in 19th, Planck has introduced a new formula, that simple formula that E is equal to HF. This is already known in physics. Okay, so I'm not explaining about this formula anymore. Okay, next, the evolution of atoms. Okay, these three students and supervisor, that is J.J. Thomson, Ernest Rutherford, and James Chadwick, has observed the electron, the proton, and the neutron of the atoms. Okay, and then the first evolution of atoms has been made by Niels Bohr. He has do a new theory based on quantum mechanics. However, the weaknesses of this theory only can be used in hydrogen atom. Okay, so bila nak guna dekat hydrogen atom saja dia boleh pakai. Tapi dia tak boleh nak pakai untuk lain-lain electronic calculation. So as a scientist, kita kena do something about it. Sebab apa? Sebab after this, kita nak predict a lot of things. Kita nak buat prediction yang banyak. Kita nak tengok what is the physical behavior, what is the chemical behavior, what is the biological behavior. So dia punya, saya tak ceritakan dia punya hierarchy selepas ini, tapi saya akan ceritakan this equation is very important. Kita ada Schrödinger, Heisenberg and Dirac. Okay, tiga-tiga ni pada asalnya dia guna approach yang berbeza. Schrödinger have different approach, Heisenberg has different approach, and Dirac has different approach. However, what Dionys Pauling said to their works, dia kata korang buat benda ni semua sama je. Equation korang ni semua sama je. In terms of simple words lah. So siapa yang publish paper dulu, Schrödinger publish paper dulu, so kita namakan dia lah sebagai Schrödinger equation. So kalau you baca buku Heisenberg, you baca buku Dirac, dia punya mathematical is very little bit tricky sikit dekat situ. Tapi dia punya application is very interesting. Okay. Okay. Next, we'll look at about the molecular structure. Okay, so Robert Mulliken has first explained the molecular orbital, and he get Nobel laureate in 1916. Okay, after that, Waterkorn and Popper, okay, Waterkorn has invented a new theory, that is density functional theory. And then John Popper, we have a semi-empirical and Gaussian. Okay, so ketiga-tiga teori ni kebanyakannya kita gunakan dalam menentukan struktur molekul, sifat fizik dan sebagainya. So kita pakailah. And then mereka ni ada anak-anak buah mereka sendiri. So nak cerita anak buah dia, saya rasa agak panjang nak cerita anak buah mereka ni. Sebab Mulliken, Waterkorn and Popper ni dia banyak anak murid dia yang belajar. So and finally a lot of electronics calculation has been made. Okay. Tapi ada dua perkara. Okay, Satu ialah bila kita sebut tentang computational in material science, dia ada dua. Satu approximation, satu lagi accuracy. So John Popper kata ada dua kumpulan. So kita nak pergi yang mana? Sama ada kita nak pergi pada accuracy ataupun nak pergi kepada approximation. Kalau accuracy, so dia punya we need a supercomputer to run the electronic calculation. Tapi kalau kita buat approximation, it's simple, tetapi kita boleh explain in the surface sahaja what is happening in this material, apa yang berlaku dekat material tu. So that's why in my research saya menggunakan machine learning untuk improve balik dia punya accuracy in electronic calculation. Okay, so in quantum mechanics, we know that h bar is equal to psi over E. Okay, so benda ni kalau nak tahu tentang quantum mechanics ni, awak kena tahu tiga perkara. Okay, if you want to know about the quantum mechanics, you have to know about three things. Yang pertama, the Heisenberg principles, this condition equation say that h bar squared over 2m, this one deal with kinetic energy. Okay, and then V deal with the voltage, the potential energy. Okay, kinetic energy dengan potential energy. Dua benda ni yang akan membezakan antara satu material dengan material lain. Yang membeza antara Watercon punya eksperimen, Watercon punya calculation dengan Popper punya calculation. Dua ni je. Okay. Yang ketiga ialah kita punya E. E kita ialah dia punya energy. So apabila kita buat operasi matematik, okay, operasi ni akan dilakukan oleh komputer. Let the computer run the iteration. Okay, komputer akan buat. So teknik macam mana, sama ada nak pakai DFT, nak pakai semi empirical, itu biar komputer yang buat. Okay, in previous, sebelum komputer jumpa, kita pakai what we call it as the differential equation machine. Persamaan pembezaan. Okay, differentiation equation machine to solve differential equation, untuk selesaikan persamaan pembezaan ni. Dulu kita pakai mesin macam ni. Okay, yang sebelah, kalau awak tengok gambar kat sebelah atas tu, kita pakai mesin ni untuk. Okay, the machine consists of arc, radius dia berbeza. So radius ni yang saintis akan setting untuk equation tu yang mana yang kita nak guna. After that, baru kita boleh simulate numerically macam mana dia punya equation dia. Okay, so itu zaman dulu zaman dulu. So zaman dulu kita pun guna, if I'm not mistake, kalau you belajar in chemistry, kita belajar S orbital, P orbital, D orbital. Kalau S orbital dia bentuk sfera, kalau P orbital dia bentuk two loops kan. So ini zaman dulu kita tak pakai komputer. So zaman dulu dia pakai yang mesin kat atas lah untuk draw the electron orbital. Okay, so nowadays kita pakai supercomputer lah untuk solve the equation. Okay, so basically in computation in material science, kita ada computation in quantum dynamics. Okay, we learn about the physical and chemical properties. We learn about the chemical reaction, and my current research, I do some toxicology about safety and health, and then a device optimization. Okay, sekejap eh. Okay, I will talk about a little bit about my research in machine learning. Okay, in machine learning, uh, we learn about how to deal with a lot of data. Okay, kita ada banyak data tu. Sebab daripada 19 sebelum Perang Dunia tu, 1914 until now, there is a lot of data in physics. Okay, so when there is a lot of data in physics, we need uh, to do some algorithm. We need to do some classification, and we need to do about the prediction. Okay, kita nak buat prediction, classification. Okay, bila kita nak buat prediction and classification, and this classification and prediction ni membolehkan kita untuk analyze and improve kita punya quantum mechanics model. So this is a tough, it's a difficult job to my research nowadays. Sebab benda yang susah lah untuk kita ni, but it's very interesting because we want to improve the physical properties and chemical properties. Bila kita nak improve benda tu, so kita gunakan realign back by using a suitable algorithm. So lebih pada algorithm, lebih pada statistical, and we go into very deeply in deep learning how the computational occur, how the experiment occur, and how the imaging occur in using the machine learning. It's very interesting research nowadays. Kalau awak juga sebagai student physics lepas ni, kalau nak pergi pada industri, machine learning salah satu bidang yang menarik lah. So normally machine learning ni awak kena sebab UiTM dia ada menawarkan short course daripada Fakulti Sains FSKM. So awak boleh join short course tersebut, and then improve awak, dia akan menjadi satu tambah nilai kepada awak punya sijil. So awak ada sijil physics dan satu lagi awak ada sijil machine learning. So ataupun data mining. Sebab data mining ni dia bukan untuk fizik saja, tapi dia boleh untuk semua bidang. Okay, so what I'm doing in toxicology analysis. So I use the quantum computational to predict the toxicology in occupational safety and health. Okay, and I improve the accuracy using the molecular orbital and using the deep learning. And finally, my work also, I'm look at how to optimize the device. Okay, and how to predict the maximum optimization in device. Okay, I think that's all for my introduction about the evaluation of physics. Okay, so thank you. Okay, Aris.
Thank you, Dr. Najib. Just now, Dr. Najib has already asked me about the difference between electromagnetic field and electric field, and I didn't get the chance to answer the question because maybe there was some delay that occurred. So let me answer the question for this now. So I think that an electric field is actually a force field that is created by electrically charged particles like electron and proton, whereby electromagnetic field Basically, electromagnetic field is a field that is created by that is created around constant uh, constant magnetic substance or moving electricity charged particle. Can you hear me, Doctor?
Okay, all right. Yeah. Okay, so okay, I have one quick chart here. Okay, so from Siti Shuhada, he said that Dr. This mean that the computer science play important role in physics research. Okay, so I'm not say that the computer science. Okay, so actually the important things is how you use. Okay, macam ni. Untuk solve equation, to solve the equation, there is a lot of mathematical equation. Okay, so for example, like square digit equation. Okay, square digit equation, we use the uh, second order differential equation. So how to solve this second order differential equation? There is two ways. Either you use the numerical method, either you use the analytical method. Analytical method tu awak kena buka equation, the table of equations and so on. So for us, we want to get very fast equation, very fast solution. We go into numerical. So this numerical we call has to run by using software. So sebenarnya dia bukan satu subjek computer science sebenarnya, tapi dia sebenarnya subjek fizik. Tetapi kita nak selesaikan masalah tu, kita gunakan algorithm. So in physics, I know in degree in physics you have computational physics kan? Ada subjek in computational physics. I'm not mistake. Ada ke? Haris, ada ke? Ke tak belajar lagi? Ada tak computational physics? Tak silap saya ada, saya pernah tengok. Ada?
Ada.
Untuk ada kan? So that one, yang tu sebenarnya ialah in physics. So we use the mathematical application to solve the equation. So that is that is the computational kira kan. Computational kira, komputer pun you know the binary code only 10101 kan. So this is the important of physics. So kita tak menggunakan algorithm yang C++ ke, kita tak gunalah algorithm tu, tapi kita using that to help us in solve a lot of things, a lot of physics phenomena. Okay, this it give us advantage to study computer science in physics. Okay, for me, if you enthusiasm to learn in computer science, go ahead. Okay, so kalau nak belajar tentang computer science, belajarlah. Sebab apa? Sebab computer science ni dia boleh membantu kita lah. Tapi macam saya bagi tahu tadi, one of the alternative solution is using the machine learning. Okay, using machine learning is one of the alternative to do the computational parts. Okay, alright, thank you Siti Shuhada.
Alright, thank you, Dr. Najib. Okay, now we will go ahead and take some time for questions. Before that, as a reminder, if you have questions that you have not yet submitted, please enter it in the YouTube comment area, and you will get through as many questions as time allows. And also, I want to announce that the Google Form link will be attached in the YouTube comment area. I hope all audience can fill in the form as for attendance and the feedback on this live talk. Alright, Dr. Najib, we have several questions for you.
Okay.
The first one is, as a first year student, what is the importance of conducting experiments and making laboratory reports? Can these skills be used in a work environment And if so, how is it? That's all. Thank you, Doctor.
Okay, this is a good question. Okay, actually, uh, as a scientist, in most of the experiment that you do in first year, especially in first year, is to prove uh, the equation, to prove the experiment, to prove the theory, apa yang awak belajar dalam first year. Okay, this is a little bit different when you go into the TVET punya area. Okay, the TVET area is different because TVET area, the skill that develops towards the needs of certain industry. Contoh, ini untuk TVET bukan untuk awak punya ni. Okay, for TVET, for example, we learn about the wiring system. We have 1, 2, and 3 wiring system, and they have to need follows all the instruction by TNB, and then you have to comply all uh, the instruction, the skills that has been set by TNB. Okay, so this one is for TVET. For our case, for scientists, awak belajar terlampau broad to prove that. So you can use your knowledge in the industry. Awak boleh guna awak punya knowledge tu dekat industri. Sebab apa? Sebab awak dah belajar secara general in the surface. Sebab universiti dia akan ajar awak secara surface saja. Dia tidak pergi kepada keperluan industri. Tapi yang awak akan guna di industri tu, awak akan retraining balik dekat industri. So some of the knowledge, yes, ada yang digunakan. Setengah itu awak kena gain your own knowledge from the industry. Tapi kalau that's why kita untuk pelajar sains ni, kebanyakan kita punya cabang tu dia lebih luas lagi. So kita boleh pergi a lot of areas. Sebab kita punya requirement dia, cabang dia kan. Tapi kalau when you go into TVET, awak punya scope dah kecil. Kalau let's say for example for TNB, TNB sajalah, untuk wiring tu hanya wiring je, awak tak boleh buat untuk yang lain. Tapi untuk ni kita kita belajar secara general, and then kita boleh develop our skill. Okay. Alright, Aris.
Okay, thank you, Doctor. And for the next question, what advice can you give to students who want to further their studies in science?
Pardon, I cannot hear.
Okay, again, what advice can you give to students who want to further their studies in science?
Okay, alright. Study in science is very interesting because you can apply in your daily life. Okay, so if you want to make physics, biology, and chemistry interesting into your work, your life, so awak kena apply awak punya knowledge tu dekat dalam kehidupan seharian awak. Okay, so this is the main core because we sometimes we do not know, we do not understand why this happen. So when you understand why this happen, maka kita bolehlah kita tahu kita gunakan kat mana. Okay, because in science stream ruang pekerjaan masih lagi banyak. Okay, okay, Aris.
Thank you, Doctor. And next is, what is your opinion about students majoring in science just because of scope of work in science majoring is vast and not because of their interests?
Okay, alright. to learn about the science. Okay, so as I know that we know that untuk kita faham tentang sains, untuk kita pupuk kita minat kepada sains tu, kita kena faham. Okay, kenapa orang tak minat sains? Why student do not know dislike about science? Sebab dia tak faham what will happen. Okay, so the fundamental to understand the science is very simple. Okay, awak apply dalam kehidupan awak, awak boleh faham apa yang awak nak akan dapat. So this is very simple. Okay, Haris?
Okay, Ratan, thank you. And next question is, in your opinion, why are some students not interested in taking the science stream when there are many benefits?
Okay. So for this question, saya pernah tanya pada my student, kenapa tak nak belajar sains kan? Okay, kenapa berhenti daripada student ni lah, sekolah kan? Some of them say that this major obstacle adalah media sosial, social media. Okay, because dia kata kenapa sir kita nak belajar, cikgu nak belajar sains, waktu saya bagi ceramah dekat sekolah kan. Okay, kenapa kita nak belajar sains? Because jadi YouTuber dia punya income lagi tinggi kan. Tapi kalau kita jadi YouTuber pun, kalau kita tak ada content pun tak guna, kita tak boleh jadi YouTuber juga kan. Tetapi kalau kita jadi YouTuber dalam bidang sains, dia punya benda ni akan jadi lagi meningkat. So apa yang awak minat? So nowadays awak minat tentang TikTok kan. So try to relate TikTok with what you learn in physics in the class using TikTok. So cubalah untuk awak applykan benda ni. So dia akan jadi lebih interesting. Orang pun akan tengok awak punya TikTok awak, dan secara tak langsung awak akan menarik perhatian orang lain untuk belajar sains. So kalau nak katakan tentang about sains tu, bagaimana kita nak menarik minat pelajar terhadap sains tu, itu memang satu benda yang bagi kami pensyarah ni satu benda yang agak sukar. So one of things that we do is, macam yang saya bagi tahu tadi lah. So itu setakat yang saya boleh kongsi lah. Okay, I think we have one question from chat. Okay, dia kata daripada Siti Suhada, dia kata doktor, sejauh mana perkembangan sains dan teknologi dalam quantum physics dan quantum physics and quantum mechanics di dalam Malaysia? Okay, untuk jawab soalan ni, quantum physics is a basic theory of physics, quantum physics, and quantum mechanics also is a basic for quantum physics and quantum mechanics, itu sama lah kan. Tapi sekarang ni saya lihat a lot of revolution using the quantum physics adalah menggunakan computational science. Okay, dalam UiTM sekalipun kita ada groups yang buat tentang computational physics juga. So this is a new things yang boleh memberansangkan kita lah. Okay, so macam kita pun, macam saya punya group pun, we use the machine learning in material science, in quantum chemistry or quantum physics kan. So ini adalah satu perkembangan yang baiklah dekat Malaysia. Okay, so satu lagi saya nak ni, most of the industry in Malaysia is not based on R&D. Industri kat Malaysia ni kebanyakannya bukan R&D. So kebanyakan hanya buat packaging ataupun manufacturing sahaja dekat sini, dekat Malaysia ni. Jadi ini merupakan salah satu pada halangan lah untuk kita kembangkan kita punya R&D kita dekat dalam negara kita. So kalau let's say katakan kita ada R&D, industri yang melabur dalam bidang R&D, so perkembangan quantum physics dan computational physics ni dia akan menyerlah. Okay, thank you. Haris, kita satu lagi, last question, boleh tak?
Last question.
Yes, last question. Boleh tak?
Kalau dua boleh Doktor, ada lagi dua soalan.
Okay, dua soalan. So, minta maaf, I'm not feeling well today. So, tak, memang saya very interested nak sharing our knowledge.
Number one, Doctor, just wondering what is exactly antimatter and what does the discovery contribute to us?
Pardon, I cannot hear.
What is exactly antimatter and what does the discovery contribute to us?
Okay. Alright. About the antimatter. Okay, the antimatter. Actually, we use the antimatter for the small parts of the atom, the subatomic of the atoms. Okay, so most of the anti-atoms, kita belajar tentang 5 types of force. Okay, kita belajar tentang 5 types of force, and one of these force ni contribute to the human life. The philosophy is very long there, tetapi dia punya contribution kepada kita kena tahu bahawa this antimatter ni dia membuatkan wujudnya benda-benda yang lain, ikat kepada atoms dan sebagainya. So itu about the antimatter. So dia punya untuk dekat negara kita, antimatter ni dia tak ada, there is no specific research group in Malaysia sebab we talk about the size less than nanometer, lebih kecil daripada nanometer, even less than Armstrong, because we have X-ray radiation to detect the matter, tapi dia lebih bawah lagi daripada bawah lagi daripada material, bawah daripada 1 Armstrong tu. Okay, alright.
Alright, Doctor, thank you. And the last question is from me myself. I want to ask that in 2012, LHC, which is Large Hadron Collider, has found a new particle, namely Higgs boson, and physicists believe that Higgs boson is responsible for the force of gravity, and it is also being called as God's particle. I want to ask is what is actually Higgs boson and why it is called as God's particle?
Okay. I'm not here very clear.
Again, in 2012, Large Hadron Collider in CERN, LHC, has found a new particle, namely Higgs boson, and physicists believe that Higgs boson is responsible for the force of gravity. And some people also call it as a God particle. I want to ask is, what is actually Higgs boson and why it is called as God's particle?
Okay, so about the Higgs boson ni memang is not my area. So memang sorry to say, saya tak boleh nak jawab that question. Okay, Haris. So Higgs boson is antimatter. So it's beyond my knowledge. So it's good to you to know that. Okay.
Alright, thank you, Doctor. If not, then one more question for you before we end the live
Mhm.
is what do you think about the future of being a scientist? Is it safe in number or vice versa?
Okay, pardon.
What do you think about the future of being a scientist?
Oh,
Is it
difficult
safe
to
in
give.
number or vice versa?
Okay, so the most difficult to be scientist. Okay, so to become a scientist, okay, as I told you earlier that, okay, so we are different from engineer. Okay, so we are deal with research. Okay, we keep continuing to do a research. We keep continuing to know a new theory. So this is about what the scientist need to do. Okay, dia akan mencari dan sentiasa mencari apa benda yang ingin improve. If you go into the industry, scientist ni dia akan duduk dekat dalam R&D groups. Okay, dia berada dekat dalam R&D group and dia yang akan monitor perjalanan research. So technician dia complementary antara engineer dengan scientist. But engineer ni dia lebih kepada parts untuk menutusahkan and do the experiment, tapi the background of the background or the fundamental or the knowledge of the research tu biasanya orang saintis yang akan cover. So kalau saintis ni, okay, so one of the things is saintis punya mindset ni dia sentiasa ingin berada di hadapan. Okay, dia sentiasa ingin uh, ke arah discover a new things. So ini saintis. Dia sentiasa ingin mencari kepuasan dia untuk mendapatkan suatu perkara yang baru. So cabaran bagi saintis ni sebenarnya ialah cabaran dari diri dia sendirilah. Bagaimana dia nak move forward untuk menjadi saintis supaya dia boleh berjaya dalam bidang dia sendiri. Okay, alright, Aris.
Thank you, Doctor. To audience, I am sorry to inform that this live talk will end 15 minutes earlier than the tentative plan because Dr. Nazib is not feeling well today. And Dr. Nazib, is there anything else you want to cover before we wrap up?
Okay, so I would like to thank you to the faculty and saya minta maaf terpaksa kita habiskan cepat program ni sebab saya tak sihat sikit. Tapi walau bagaimanapun saya ucapkan terima kasih lah untuk menjemput saya pada hari ini dan saya cuba yang terbaik untuk share knowledge kepada awak semua dan knowledge ni suatu benda yang agak luas. Okay, dalam fizik saya macam Haris tanya tadi pun ada ada benda yang saya tak boleh jawab tadi kan. Sebab knowledge ni terlampau luas. Ilmu Allah Subhanahu Wa Taala ni terlampau luas. Jadi carilah ilmu tersebut. Walaupun kita ada PhD, walaupun kita ada ijazah sekalipun, kita akan sentiasa mencari ilmu. Okay, so saya punya pesan saya, walaupun awak berada dalam bidang fizik, so awak boleh bekerja sebagai technician even di industri awak boleh bekerja sebagai manager dan sebagainya. Sebab apa? Sebab graduan UiTM ni memang graduan yang sentiasa dinanti-nantikan oleh industri. So siapa kita adalah mencerminkan diri kita sendiri. Okey, itu saja. Sekian.
Thank you, Dr. Najib. That was absolutely an interesting sharing session we had there with Dr. Najib. As for me, moderator, I hope that the information shared during the session today will inspire our fellow audience on the towards of the evolution of work. Thank you, everyone. We appreciate your contribution. And also thank you to Habib, our host for webcast at FSD and the committees involved in this live talk. And kindly reminder that don't forget to fill in the form at the link at comment area. And thank you again for joining us today, and we will see you next time. Assalamualaikum warahmatullahi taala wabarakatuh, and good evening everyone. Thank you, Dr. Najib.
Sama. Okay, terima kasih semua. Thank you very much.
Thank you.
Okay.
Again, kindly reminder to all audience, do not forget to fill in the form at the YouTube comment area as for attendance and the feedback for this live talk. Thank you again. If you have done that, and that's all for tonight, and that's all for me as your moderator. And Assalamualaikum warahmatullahi taala wabarakatuh, and thank you again. Assalamualaikum.
Okey semua, selamat malam. Assalamualaikum. Jumpa lain hari, lain waktu, lain tempat.
As a gamer, you know how